All right, we are on lesson 5, solving multi-step equations, and this is going to be part 1. We're just covering this page, this first page. So let's kind of review. Notes, part A. Do you remember the distributive property? Because we're going to be using it a lot in algebra. Here, right over here is our distributive property. So go ahead and put a fancy little box around that. The distributive property, just a review, for any numbers a, b, and c, so we could have whole numbers, fractions, integers, negatives, whatever. If I have a times the quantity b plus c, that means that I am multiplying a times b plus a times c. So that was what that means. And you can go opposite. If I'm multiplying b plus c and I'm multiplying it by a, I'm still multiplying a by b and a times c. Same thing works with a negative. If I'm multiplying a times b minus c, I'm multiplying a times b minus a times c, and it obviously goes backwards as well. Here's an example. If I have 10 times x plus 2, that means I'm multiplying 10 times x plus 10 times 2, which is 20. So that would simplify to 10x plus 20. So there's our review on the distributive property. Another note to remind us, when evaluating an expression, we are using PEMDAS. So remember PEMDAS, please excuse my dear Aunt Sally. When you are solving for an equation, we are actually going to undo or unravel our equation. We're going to do PEMDAS backwards. So we're going to do an example where you can see how we're going to set up this equation and then how we're going to undo it. We're going to unravel or do it backwards. So Wilbur takes his age in years, adds 9, and then divides the result by 7 to get 4. How old is Wilbur? Well, let's go ahead and set up an equation here. And I'm going to do this kind of a different way. He takes his age in years, so I'm going to call his age A. There we go. So this is Wilbur's age. He adds 9 to it, so I'm just going to draw adding 9 to it. And if I want to write this as an expression, this would be now A plus 9. Then he divides the result by 7. So now what I'm going to do is divide that by 7. And what does that look like? Well, that looks like A plus 9. This whole thing is divided by 7. To get 4, that means this amount is 4. So really, my equation is a plus 9 divided by 7 equals 4. Okay, that's my equation. Now, in order to solve this, I want to work backwards. So what did I do last? That's what I'm going to start by unraveling first. And by unraveling, we're going to do the inverse operation. So I divided by 7. Well, how do we undo division? We multiply. So I'm going to multiply by 7. So that becomes, let's see, well, what happens if I multiply 4 by 7? Well, I get 28. So I know that a plus 9 is going to equal 28. Okay. Now, the first thing I did was I added 9. Well, how do I undo addition? I subtract. The inverse of adding 9 is subtracting 9. So I'm going to subtract 9. What's 28 minus 9? 28 minus 9 is 19. Therefore, Wilbur is 19 years old. Now, so this is kind of a visual representation of what we're doing. Let's go ahead and do the algebraic. We're going to do the exact same thing. It's just going to look a little bit differently. Obviously, this is pretty time-consuming. This is going to be pretty quick, but I wanted you to see the visual so that you can know why we're doing what we're doing. So here we have this. Let's see, I know that I need to divide first because my numerator, it's kind of like it's an invisible parentheses. I can't touch my numerator until like I get rid of the division. So I'm going to multiply by 7. Multiply by 7. I get a plus 9 equals 28. Ooh, now I still want to get a by itself, so now I'm going to subtract 9. Subtract 9 to both sides. Those cancel out, and I get A equals 19, right? Am I doing that right? Oh, I just had a brain fart about subtracting. Ugh. So he's 19 years old. Let's go ahead and do example 1. Let's see, I have 3x minus 6 divided by 3 plus 9 equals 18. Well, this is saying, if I'm thinking about it visually, I have a mystery number, I multiply it by 3, then I subtract 6, then I take that whole value and divide it by 3, and then I add 9 to get 18. What's the last thing that I did? Is this 9. So I'm going to start unraveling this by subtracting 9. I get 3x minus 6 divided by 3 equals 9. All right, the next to last thing that I did was I took this whole value and I divided by 3. So I'm going to do the inverse of that and multiply by 3. So multiply by 3, multiply by 3, I get 3x minus 6 equals 27. Next thing that happened was I subtracted 6, so now I'm going to add 6. 3x equals, what is that, 33? And then I multiplied, so now I'm going to divide, and I get x equals 11. And we can definitely go ahead and check our answer. The nice thing with algebra is you can always know if you get the right answer or not, because you just plug it in your calculator and see. All right, let's check it. 3 times 11 minus 6 is 27. 27 divided by 3 is 9. 9 plus 9 is 18. Woohoo! Did that right. Now, I really want you to know how to show your work algebraically, especially with these simpler problems. You might think, oh, I don't need to, but we're going to get into some pretty nasty, complex stuff that you're going to have to be able to show your work on, because your answer might not be a whole number. It might be a fraction or a decimal or irrational. And if you don't know this process, you're not going to be able to figure it out. So practice the process. I want you right now to go ahead and do Math Maze number 1 on the back side of your packet.